Hello, Professor. Our team name is Cloud Commandos. We are created a securing cloud-hosted LAMP and WordPress stock and AWS. Our main agenda was overline and approach, baseline development and test, network hardening, host hardening, application hardening, retests and what the findings has been happened, and the challenges and the conclusion of live demos in the upload project. The main project and overview was our workload was is a standard LAMP stack running WordPress on Amazon Linux instance on a cloud service like the providers secure the hardware, but we as a tenant secure the operating system, the application and the data. We set as a four objectives: deploy the site, harden each and every layer of the site, test before and after, and record each findings and risk rating and evidence. Our approach resets at two ideas: defense in depth, so one failure does not open the whole system, and least privilege as nothing access, more access. That it is. On the diagram, internet users such as Apache ports 80 and 443, admin access port 22 is limited to a single database. The database on the loopback interface, so no outside client can reach it. If CloudTrail, CrowdWatch, and config watch the account activity and any change that reopen a port. Baseline deployment. We launched a small EC2 instance running on Amazon Linux. To create a true starting point of the security group, we we left wide open ports like including database port open 3306. We connected over SSH, shown on the top right in the image, and installed Apache, PHP, and MariaDB. The Apache test page on the lower right confirms the web server was live. We then created a WordPress database and choose admin name other than the default. The result was working site is in a deliberately weak state and ready to measure.
I ran a full length and map scan from an outside machine. The result on the right is the headline problem port 22 and 80 answer the whole internet. The port 3306, the database is open and reachable on the website. WordPress leaked the admin name in the version. XML or PC was enabled and also the login page ran our plain HTTP. This is our before picture. Every item here becomes a finding. We fix and retest.
Network hardening in AWS layer. We removed 3306 port and database only loopback. SSH is restricted to one admin address. Kept only 80 and 443 port public. CloudTrail record every account action. CloudWatch alarm on high CPU and AWS config any reopen port.
First time, we, we started the operating system by adding some secure measurements. First, we use filed for as a secondary layer of the file potential. Allows only SSH and HTTP and HTTP traffics. Then we install Bell2 patching, which blocks an IP address after 5 attempts to prevent more, more insecure features. We also enable auto secure update using DN Automate. So the systems stay up to the date. Finally, we disable password and root logins for SSH. And also only SSH key authorized making remote access such more access. Next, application handling. Next, we secure the WordPress application. We enable HTTPS using HTTL to encrypt communication between user and the WordPress. We install WordFriends, which provides web application firewall and malware scanner. To improve login security, we enable two-factor authentication. So administrator must enter both password and one-time code. We also hide the draft login page, limited login items, disable XML, and hide the wallpaper version to reduce the risk of the attacks.
I ran the sum test again. The nmap result on the top right is the port 3306 is gone. SSH answers only our address and 443 now serves a TLS. On the website, the lower right shows XLML RPC returning access denial and the default login now returns a not found. User enumeration is blocked and the site loads over the HTTPS placed next to the before scan. The pair is the clearest evidence that the hardening worked. And also, we recorded 10 findings, each with before and after evidence. At baseline, we had one critical for high and 5 medium issues. After hardening, every finding drops to low residual risk. As the chart shows, the two changes that mattered most were closing the database and restricting SSH, multi-factor authentication, and TLS. Then close the authentication and transport camps. My friend will continue the next part.
Here is the findings and risk ratings. And we need to show our live demonstration evidence of our project. Let's go to the portal. This is a AWS server. Before it will be yellow color before starting the AWS. After clicking the AWS, click on Start Lab, and after a few seconds, it will be green color. Just click on AWS. And go to EC2 instance. Click instances and select, click connect. Here, now next my friend will continue here. Sorry.
Input is need to copy the IP address and you need to give here. Next, we need to give SSH, customize. Then we need to close the profile we have downloaded from the EC2. We'll open a terminal like this. We need to connect EC2 and AWS to PuTTY. Here we need to install MongoDB and database procedure Ubuntu. Then we need to give access to WordPress. Next, my friend Vishnu is going to continue.
Yeah. Due to the video and in my working time, we capture the some solutions. Now, I will explain the description. The first one should be the first screenshot shows create WordPress. In the next screenshot is HTTP allocated. And another one is MariaDB secure installation. And another one is Gold Plus download. And again, WordPress install this screenshot source. And this one is set a WordPress installer language page. This is the
And here is a screenshot we have captured by our group. And
during the project, we face several challenges. The AWS YAML lab prevent us from creating IAM user. So we document how distributed access would be implemented in a real environment. Since we did not have a domain name, we used a self-signing SSL certificate instead of one from a trusted certificate adopted. We also used the free version of WordFence, which has fewer features. Now my friend explain.
here is the conclusion and lessons of this. And we have done our contributions. Thank you.